We're on page 82. The problems that we're going to do are 7F and 7N here. And we're going to do 8D and finally 8H. So 8D and 8H. Now 7F. Here's the problem, and the only thing we're going to do here is, because we want the denominators to be the same, and we can do that if we put the x squared where the 4 is and the 4 where the x squared is. In other words, we interchange these two terms, keep the minus, then we just change this sign and it becomes plus. And when you do that, you can see that 4 minus x squared becomes x squared minus 4. We have the same common denominators here, so we can just add the numerators. Now we have x plus 2 over x squared minus 4. We can factor x squared minus 4 as x plus 2x minus 2. Cancel the x plus 2 in the numerator and the denominator, and I'm left with 1 over x minus 2 as the answer. In this case, we have 1 minus 2x, 1 plus 2x, and 4x squared minus 1. Now what we can do, we're going to rewrite the problem right here. And the only difference, this term is this term, this is this one, and we're factoring 4x squared minus 1 as 2x plus 1 and 2x minus 1. So in going from here to here, line 1 to line 2, the only difference is this is a difference of squares. 2x times 2x gives me 4x squared. The inner and outer cancel to 0, and plus 1 and minus 1 multiply together give me minus 1. So that's the only thing in going from this line to this. This has stayed the same, and this has stayed the same. Now, let's take a look at this denominator here. You got 2x plus 1. And you just switch it to 1 plus 2x. That's all. No sign change or anything, because it's like saying 3 plus 4 is equal to 4 plus 3. So we're just reversing this. But what we're going to do is change this one, 2x minus 1, put this term here, put this term here, and then change the sign here. That's very important. Now, why would we do that? Because then this part here, this term becomes identical with this one. So let me repeat that. This part here, this term is just, the terms are just reversed. That's all. We just do it because there's a plus here, and we just, if we have 2x plus 1, it's identical to 1 plus 2x. The 2x minus 1, we put the 1 here, the 2x over here. This is a minus, and this sign changes from plus to minus. Now, this term in the denominator is identical to this, and this term in the denominator is identical to that. Now, to what's the next step? Well, we find the lowest common denominator is 1 minus 2x, 1 plus 2x, 1 minus 2x, 1 plus 2x. That's the lowest common denominator. And divide the lowest common denominator by each term's denominator, and then multiply the numerator by the quotient. What does that mean? We take the lowest common denominator, which is that. We divide by this term's numerator. We get a quotient of 1 plus 2x, which we then multiply by this numerator here. Oh, we multiply this by that. Okay, here in the second term, take the lowest common denominator always, divide by this term. That leaves me with this, and I'm going to multiply the top of this by this 1 minus 2x. In this case, in the third term, I've got 1 plus 2x, 1 minus 2x, 1 plus 2x divided by the same thing. These are identical. Type's a little different, but these are identical and it becomes 1, so I don't really have to do anything. 2 times 1 is 2. So let's repeat this again. I first of all establish my lowest common denominator, which is 1 minus 2x, 1 times 1 plus 2x. Divide this low LCD by each term's denominator. So I'm going to divide each one by their own denominator and multiply the numerator, this, by the quotient. So here 1 minus 2x, 1 plus 2x is the lowest common. The first term, there's the denominator. This is the quotient. This is the quotient. So I multiply the 1 that's existing here by the quotient. Here I do on the second term the same kind of thing, except I'm going to divide by 1 plus 2x here. I'm left with 1 minus 2x, going to multiply 3 times this quotient, 1 minus 2x. This one, if I divide this essentially by itself, I get 1, so I'm just really going to multiply that by 1, which doesn't change anything. Now I'm going to remove the brackets. This is 1 plus 2x. Minus 3 times 1 minus 2x gives me minus 3 plus 6x. And then minus 2 times 4x gives me minus 8x. Minus 2 times minus 1 gives me plus 2. When I collect all the terms, what happens? 1 plus 2 is 3. Minus 3 gives me 0. 2x plus 6x gives me 8x. 8x minus 8x gives me 0. So the sum of these terms all sum to 0. Well, if there's 0 in the numerator, I divide by the denominator, the answer is 0. So that's basically how we do this problem. And the key thing is to get this lowest common denominator and understand this part. This is the quotient, and you will always multiply each term's quotient by the numerator. So these are the quotients, and we multiply the numerators in each term by their respective quotients. Okay, now this problem here, I'm going to show it like this. Okay, so what we're going to do is handle the numerator of this problem. I've just rewritten the problem here. Here's the problem. We have to simplify this. So if you go back, the object is to simplify it. And okay, so what we do here, we're handling this as the numerator and this as the denominator. So first of all, let's look at the numerator. The lowest common denominator is always the product of the two denominators. So in this one, x is x over 1. So this is x over 1, and this is x. So if we take 1 times x, x is the lowest common denominator. Now, as you remember, as we did in the last problem, we divide the lowest common denominator by each term's denominator and then multiply the numerator by the quotient. This is the quotient here. So here's the lowest common denominator for the numerator. And we divide by the denominator of the first term. Well, the denominator for this is x over 1, so I divide by that. X over 1 is x, so I get x as a quotient. I'm going to multiply this by x, and I get x squared. Now I take the second term. The lowest common denominator is x, because it's the same as it is over here. I divide by that second term's denominator, which is x, and I get 1. I take this 1 and multiply it by the y squared, and I get minus y squared. So that's how I get this. I multiply this term by x, I multiply this term by y, and here's my LCD, because I must always put my LCD in. Now, let's deal with the denominator. Well, the LCD is identical because this is over 1 over 1, and here the denominator is 1. I multiply 1 times x, and I get x. So again, the LCD is x. Take the first term. I divide the LCD by the denominator in this first term. It's 1, and I get x. So multiply x times 1, and I get x. Now I go over to the second term, which is right here. I divide the LCD by the denominator in the second term. I get 1, and I multiply 1 times y, and I get y. Here's my LCD for both of them. Now you'll see that here, the denominator here cancels with the denominator here, and I'll explain that in a minute. I'll come back to it in a second. Just accept it for now, and I'll explain why. So these denominators cancel. I'm left with x squared minus y squared over x plus y. This factors as x plus y, x minus y, the difference of squares. This is just x plus y. I cancel this and this, and I'm left with x minus y. This is just a software glitch. Don't pay attention to it. Now, what about this here, canceling the denominators here? Well, let me just show you why that is the case. Okay, canceling denominators when they are the same. So let's say we have x over a over y over a. This is really x over a multiplied by a over y. I flipped this, invert and multiply. So the a's cancel, and I'm left with x over y. X over y. So if I cancel the a here and I cancel the a here, I get x over y. So that's what I did over here. I'm allowed to do that. If the denominators are identical, okay, in a ratio, in a complex fraction here, if the denominators are identical, I can just cancel them. Okay, 8h. Now, here, if we look at this numerator, there's really nothing to do, so we leave it pretty much the same. I'm going to leave it the same. I'm just going to write it again over here. Now, here, for the denominator, I need a lowest common denominator, and I multiply this times this, or 1 minus x squared. So now, I have to divide the LCD by each term's denominator, and then multiply the numerator by the quotient. So in this particular case, my LCD is 1 minus x times 1 plus x. I'm going to take that and divide it by this term's denominator, which is 1 minus x. Leaves me with a quotient of 1 plus x, which I'm going to multiply 1 times 1 plus x. I take the second term here, take the LCD, divide by the second term, I get that. The quotient is this. I multiply this by 1 minus x. So then, again, the denominators in a complex fraction, if they're identical, can be canceled for the reason we gave in the last problem. I have 2, which is this 2, over 1 plus x here, minus 1 plus x here when I remove the bracket here. Minus 1 times 1 gives me minus 1. Minus 1 times minus x gives me plus x. So I now have 2 over 1 plus x minus 1 plus x. 1 minus 1 is 0, and the x's sum to 2x. The 2's cancel, and I'm left with 1 over x. And that completes the page 82 problems.